I'm Connor Walls, and I'm here once again to talk about embedded software. Today I want to talk about real-time operating systems, and specifically I want to be looking at how to measure their performance. Now, there's lots of reasons why you want to measure the performance of an RTOS, one of which is you're trying to choose one for your application and you want to make sure that you're going to get something which will do the job. The way you might do that is to look at the data sheets from the various vendors and try to figure out what the performance figures all mean. Now, this is quite a big subject, and I'm going to focus on a small part of it today, which is interrupt latency. So, interrupt latency is broadly what kind of delay is there between an interrupt occurring and something being done about it. I'm a little vague about what interrupt latency really means there. And that's intentional because so are the RTOS vendors. Different terminology is used by different vendors. They're not trying to lead you astray necessarily, they just have different priorities and different ways of expressing the idea. Broadly speaking though, there are two different ways of looking at it. We can look at what I would call system interrupt latency and OS interrupt latency. Look at my diagram here. The OS latency would be any delay introduced between the interrupt being acknowledged and the interrupt service routine actually being executed. Now, in many cases, there's no delay at all because the operating system doesn't get in the way. In others, there will be a delay. So some vendors claim zero interrupt latency, and what they mean is a zero OS interrupt latency. The alternative delay is system interrupt latency. In other words, the time from the interrupt signal being asserted to something being done about it. And that is going to be a longer period of time. There will always be some kind of latency, so zero latency is impossible in that respect. However, it will vary quite a lot from one RTOS to another. Now, if you're trying to understand what it says on data sheets, you'll see numbers there. You need to figure out which of these they're talking about. And then you need to make sure that they are using the same platform. You're comparing similar systems. The measurements have been made on similar systems. So what are the factors to think about? First of all, there is the platform and the interrupt controller. Which device, which board is it running on, and what interrupt controller is in use. Next one, rather obviously, is clock speed. What speed is the processor running at? That's going to affect the interrupt latency, of course. Cache configuration. Software's execution performance is affected drastically by the way cache is used. So knowing how the cache is being used, is the OS locked into the cache, for example, that kind of thing. The timer frequency. This may seem irrelevant because we're not using the timer, but the timer is a background high priority interrupt. And the faster, the higher frequency it's running, the more effect it will have on the overall system performance. So you need to know that. The RTOS is running out of memory of some kind. If it's running out of flash, it will be slower than if it's been copied into SRAM and running out of there, which is very common practice. Again, you need to know. And lastly, how was the kernel built? Was it built with careful optimization for speed? Well, you need to know that because if it was, then you're seeing the best possible number that was under different circumstances. The OS may be built in different ways. At the end of the day, the best way of ascertaining the interrupt latency is to measure it yourself. In other words, assert an interrupt and see how long the delay is before your code is executed. Simple it sounds. It isn't that hard to do. All you have to arrange is that when the interrupt signal is asserted, a GPIO pin is used at that point, is triggered at that point, and another pin is triggered when you enter the code which is going to service the interrupt at the end of the day. You monitor those two pins on an oscilloscope. That shows you the time delay graphically across the screen. You've got your interrupt latency. If you're afraid of using an oscilloscope by yourself, find your friendly hardware counterpart and have a chat with them. I'm sure they'll help. Software engineers tend to be afraid of using instrumentation and hardware-y stuff. Work as a team, that's the best way forward. And that's good advice in general, actually, but in this context, I think it's an ideal opportunity to liaise. That's all on measuring RTOS performance for today. This is a subject I will probably come back to and look at some other aspects of on another day. But for now, that's a lot. Bye for now.